Hello and good morning, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Net Plus course, Introduction to Networking, and today's tutorial is going to be the answer, key, and solution set for the Unit 7 worksheet, where we're going to be taking a look at subnetting Class C addresses. So one of the first questions you need to ask yourself when we're subnetting is, how many subnets do I need? And so remember that to answer that question, all we need to do is simply take the number of borrowed bits, let me change the color here to red, is take the number of borrowed bits and raise 2 to that power. And that's going to give us the total number of subnets. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, and 2 to the 6, which is where we end up here, is 64. Excuse me. And so this answers the question, how many subnets am I going to create? It's all based off the number of bits that you are borrowing. And since we're talking about Class C, we're going to be borrowing from that last range of octets. If this was Class B, and let's say we had 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. Now we're talking about 16, 4. We're talking about 16, 2, 3, 4, 5, 6, 7, 8. 16 bits from which we could borrow, because remember, the default mask for a Class B is a /16. So if I borrow that bit right there, I still end up with 2, and then 4, and then 8, 16, 32, 64, 128, 256, and then it just continues to increase and double, right? 512. This one here would be 1024. So you get many more subnets when we're dealing with a Class B address. So when we're going to jump back to Class C, here are the Class C addresses, and again, we're talking about that fourth and final octet, which is all host bits, and we're going to come in there and borrow some of those bits. And that is how you end up with the right number of subnets for whatever your use case may be. Now, how many host bits do I need? Remember that the equation to calculate the host bits is going to be 2 raised to the number of host bits minus 2. And that gives me the number of usable IPs in that subnet range. So we kind of do this in reverse order, right? So if 6 of those bits have been borrowed for network bits, that leaves us 2 host bits. So we're going to have only 2 usable addresses. Here we get 3 host bits, so 2 to the 3 is 8 minus 2 is 6. 2 to the 4 is 16 minus 2 is 14. 2 to the 5 is 32 minus 2 is 30. 2 to the 6 is 64 minus 2 is 62. 128 is 2 to the 7 minus 2 is 126. And then if we had them all, it would be 256, but 2 to the 8 is 256, but minus 2 is 254. Now remember, the 2 that we are subtracting from this equation, the 1 address is going to be your broadcast address. Let's put down bcast here. The other address is going to be the subnet ID. Whoops, left out the end there. Subnet ID, or sometimes you'll hear it referred to as the network ID. But in both cases, every time we're trying to figure out the number of usable host IPs, we're going to subtract 2 after we do 2 raised to the number of host bits. All right, let's clear the screen here, and let's scroll down a little bit. Whoops. All right, so now it's our turn to go ahead and complete the subnetting information here. So we've got a Class C address listed for us here, the 210.100.25.0. Now remember, once you get the block size, if we're going to be doing subnetting, you're going to be able to get all the other information you need. So here's the default Class C subnet mask, right? It's a /24, so the first 24 bits are all network bits. meaning the last 8 bits or this last byte or octet, these represent the host bit. So by default, we have 254 usable IPs. Now let's take a look at what we're being asked to do here. Your company has 8 departments. Each department needs to have their own subnet. Create 8 subnets. And again, very, very easy to do here. If I need 8 subnets, I simply say, okay, 2 to the 1, if I borrowed 1 bit, is 2. So we'll say 2 to the 1 equals 2. If I borrow 2 bits, that's going to give me 4 subnets. If I borrow 3 bits, that's going to give me 8. And so here we go. Create 8 subnets, which means I need to borrow 1, 2, 3 host bits. So now, what is our subnet mask? Well, the subnet mask in CIDR notation is pretty easy. We know that the first 24 bits are the default, so then we've got 25, 26, 27. So we have a /27. If we were to work this out into dotted decimal, it would be 255.255. And again, the values are already right here in front of us. 255.128 plus 64 is 192, plus 32 is 224. So a /27 is 255.255.255.224. Now, what about block size? Right? Remember, all we need to do is get the rightmost bit value from the borrowed positions, and in here it's going to be 32. So we know right now that all of the subnets we're going to have are going to be .0, .32, .64, .96, .1, what is that going to be? Hold on a second, 96. Yeah, 96, 32 is 108, or 120, sorry, 128. 128, 160, oops, not 168, 160, 192, and then if we were to say add 32 to that, we're going to get 224, and how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So there are my 8 subnets. Remember, if I added 32 over here, I'd get 256, and we can't go up to 256. So we know that this network ends with the broadcast at 255. This one here is going to be .223. This one here is going to be .191. Again, just one less than the network ID of the following subnet. .159, .127, .95, .63, and .31. And so here are all 8 of the networks that we have created. So the new subnet mask in binary, we've got it up here, but let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot. We borrowed the first 3 bits, leaving 5 host bits. So that is it. So highlight the rightmost 1 bit in the binary mask. It's this guy right here. And the decimal value will be 32. And so here are all of our networks, and this is exactly how you would sort this out. Again, if you can get to the block size, it's going to be game over. Whoops, sorry, it's going to be game over. So let's come down here. The new subnet mask, oh, this is just asking, I believe, some additional questions about what we just did. So the new subnet mask creates how many subnets? So creates 8, and 2 to the 3, oops, sorry, 2 to the 3 equals 8. Each subnet has how many possible hosts? Well, there were 5 host bits left over. That's 32. 2 to the 5 is 32, minus 2 is 30. So we could have 30 possible hosts. So fill in all the subnets first, then all the broadcasts, and then all the valid host addresses. So again, they're going to show this is 32. And wait a second, let me see how far down this goes here. We may need to adjust. Does it roll to the next page? All right. So we'll leave it right there. Actually, let me clear the screen here. So again, the valid host IPs would be .1 to .30, not .31, but 31 is the broadcast. So let's fill these in like this. So we'll say .32, .64, .96.128.160.192.224. So then for my broadcast addresses, again, it's just one less than the next subnet. So .63, .95. We kind of already did this, but we'll do it again. It doesn't hurt to get a little extra practice in. .159, .191, .223, and .255. So then our usable IPs are what falls in these ranges here. Again, .33 to .62, .65 to .94, .97 to .126, .129 to .158, 161 to .190, .193 to .222, and then finally .225 to .254. And so that is basically everything we just did above, except placed nicely here into this chart. And then we can allocate these subnets out and say, okay, this is going to be HR, this is going to be the IT guys, this is going to be marketing, this is going to be sales, so forth and so on. All right, so let's clear the screen here and let's scroll down just a little bit further. All right, so there are multiple ways to write the subnet mask, and we've seen this. We can do it in binary, we can do it in CIDR notation, we can do it in dotted decimal format, and this is asking us to fill in the CIDR notation, subnet mask in binary, and the subnet mask in decimal, given some of these values here. So actually very straightforward, right? So a /25 is simply going to be the first 25 bits, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's what it would look like in binary form, because again, the first 25 bits going from left to right will all be 1 bits, representing that CIDR notation. And then that gives us 255.255, because again, when all of the 1 bits are on, the max value is going to be 255, and then 255 dot, and the value of that bit position, right, and then no other bit positions are on, is 128. So now we come over here and we've got to figure out, okay, we've got this binary notation here. What is the CIDR notation? Well, very simple. So we've got 8 plus 8 is 16, plus 8 is 24, and then we have how many more network bits? 1, 2, 3, 4, 5, 6. So 24 plus 6 is going to be a /30. And then again, we put the subnet mask in dotted decimal notation, 255.252. And that's our /30. So then the /28, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8. So that's 24, 25, 26, 27, 28, which means our last 4 bits in that octet are going to be all zeros. My subnet mask is going to be 255.255.255, and then what are those values added together? Well, 128 plus 64 is 192, plus 32 is 224, plus 16 is 240. All right, and now we've got this final one here where we take a look at the 4th and final octet. We've borrowed 1, 2, 3, 4, 5 bits, so this is a /29. Because we only have 3 non-network bits left. So what is this in dotted decimal? It's going to be 255.255.255 dot, and if I added those 5 bit positions up, well, the one right above it we had 4, and that was 240, and so then I just add in this 5th one here to give me 248. All right, well, this is going to wrap up Worksheet 7 on subnetting and working with the subnet masks and the CIDR and binary and dotted decimal format of those subnet masks for Class C addresses. All right, guys, remember there's no class on Tuesday evening. Enjoy your spring break, and I will see you all when you return. Have a great weekend.